Hey guys, it's Danny here of Class D Power Amplifier project, and in this video, I would like to share to you my experience of using the PC-based DSO2820. This is the one at my back, at my left, and the other one here is the QA401 from Quant Asylum. I'm having a little problem on the bridge style load configuration as I'm testing the TI chipset, the Class D power amplifier with an analog input, particularly the TPA3255. A little bit messy because of the bridge style load configuration with respect to the grounding of the PC and also how to isolate that with the traditional equipment that I have. So I thought of taking this video and share it in my YouTube channel just in case anyone is planning to buy a PC-based equipment like the DSO2820E from Multi-Instrument and the QA401 from Quanasylum with a working PC that drive this equipment. Alright guys, before I'm going to discuss the problem, let me first show to you about the multi-instrument VTDSO2820E. The upper waveform is a sine wave and it displays right now a 1 kilohertz signal sine wave at a magnitude or amplitude of 2.6. That is about nearly 1 watt output power from an 8 ohms load. And I can compress and expand the sine wave. The lower graph is the spectrum, which shows that this signal in here is 1 kilohertz. The span is from 0 hertz to about 2 kilohertz. And it shows that at 1 kilohertz, we get a peak signal with an amplitude of 2.62. So go back to the upper waveform. It shows here two signals. One is in the yellow and the other one is the pink one. Maybe I need to show to you the yellow one. This is the yellow one now. You can see here the clock frequency from the Class D. That's all right for now. It's a little bit scary. And then what I'd like to show now is to put the two signals together for the left and right. By the way, the yellow one is the left channel, and the pink one here, so superimposed together, is the right channel. What I can do to separate, I don't know exactly how to separate the two signals to make it clearly see. What I'd like to do in here is to make it smaller. And I change the trigger to B. There you go. So the smaller one is the left channel and the bigger one, the pink one or the red one, is the right channel. I'd like to actually superimpose them together, but in one of the module of the class that I obtained from the e-commerce in Taobao, it's not really working. And I found it out later that it's because of the grounding system. So let's define what is the problem. So here is the problem right now. I superemphasize the DSO2820E and with the left signal only. That is the one with the problematic, and I remove the right channel input. So this is the right channel input or the channel B for the DSO2820E. And what's the signal in here? When I just put the grounding in here, you can see it reduced. That is the problem. It reduced to about from 2.8 to about 1.9 volts, and that is a problem. I suspect initially that the boards, the module B that I'm testing, the TPA3255, has a problem, but eventually it's not. So if I'm going to put the one, that's how it looks like. It's actually have some problem and I cannot display them together. Just to be fair, if I'm going to remove this one and then put that into the channel B, and we get a signal, put the trigger in the channel B, and it's quite stable. So if I have only one input signal to the DSO, the 2820, and there is no problem. I'm going to put the trigger in the channel A, and there is no problem. Again, you can see that if I'm going to put that one, it is reduce the signal. I can use the right channel actually if you'd like. That is the capture from the right channel right now, and this is the left channel, and you can see what is going on. I just put into the supposed the reference ground. I suppose that the connection the board, I call this one is the left channel and this is the right channel. So you can see from the speaker wire we get the, I can say this one is a live one and this is the GND. That is evident for SE mode, that is the single-ended mode. But my understanding about Class D BTL, the bridge tidler, is that both the left, the left and the right channels, they're actually not reference to ground. That is why I put it in the same way. This is the live one. This is also the live one for the right channel. And this is supposedly for the GND. Let's just say like that. And I put it in the same way. That is a uniform that I've been using in the SE mode, the single-ended. And my connection should be right. Also the way I put, let's see how I put that into the resistive load. So this the BNC, this is the black one, which is supposed to be the reference for ground. That is only evident again for SE. And this is the plus one, the red one, the red one. So are both the same. And of course, there's no effect on the, oh, what happened here? The effect on the offset voltage, which I'm using that for monitoring. And that's how it looks like. I think my connection is pretty uniform based on the SE mode style with all the polarities in the same. And I'm still getting a wrong output waveform from the PC DSO 2820E, and that is really the problem. I actually tried another board which is also the same chipset but different board. I call it as the Module A, which is this one, and it works pretty well. It's pretty good. And also I tried another one which is I call it just the Module C, which is it works pretty good as well. But I'm not so sure what is so special about this board that it behaves like that. This one in here. This one in here. Oh damn. That's the reason why it reversed. It reversed. Damn. So I can see the problem, though my connection here is uniform. This connection in here for the DSO, this is red also, this is black. But the color here is the live one for the red, and this one is reverse. This is the live one, which is connected at the black, and that makes the problem. Cheese, the problem is here. Alright, so let me power it again. There you go. That is for the left channel, and this one is for the right channel. And I'm going to, let's see, there is no more reducing the input signal, so I can put it right now in here, and now we get the two signals together. Whoa. Finally, problem solved. It took me almost like a half day to solve the problem. I'm not able to see my mistake on the connection because of what I'm thinking actually is that a Class D power amplifier, the BTL is floating, and I don't need to observe exactly which one is a plus, which one is a minus, which one is a plus and minus, not like the SE mode, the single-ended, that I need to observe which one is the ground and which one is the live, and the ground is common to both the left and the right channel. I tried to implement that one actually by the color-coded wires, but somehow I made a mistake. And basically, I can explain that the input signal actually of the TA20E, this the BNC grounding in here, is not actually isolated, but only this time that I had a problem with the 2A20E, dealing with the Class D power amplifier or the BTL output. It's my first time actually. I told you that I have two modules. This is the same chipset TPA3255, and the other one in here is the TPA3255 also, but different form factors, and it works. And that is a little bit a mystery. I think that the module B, the module A, and the module C are the same chipset, but different hardware design and different configurations. And the only problem, the only thing that I'm having problem right now is this module B. That is why I need to dig down to the real root cause. Probably there is still something wrong with this board in there, not only my connection. It's because I don't experience that with this module A and the module C, and that is the reason why I'm trying to point out that there must be something wrong in here. Maybe not something wrong, but the circuit is basically different. Finally, problem solved. Problem solved. So that means to say that using the 2A DSO 2A20E, you still need to take care of how this BNC is connected, making sure that you follow the same way it is connected, not in the reverse way, so that it will be uniform. I believe, my belief right now, that the BNC GND is basically connected to each other, and it's not a separated or not a floating, and that is the reason why I got the trouble. But I don't know that before, because all what I know is I'm looking at the Class D power amplifier, that module B, that BTL is basically no polarity, and that's the culprit. My mind is focused on that. I'm not focusing on this DSO 2A20E, how it is connected. So let me put back into its place. I just use the tripod to re-emphasize it, and then put together with the QA401 so I can measure the distortion. There is a distortion for the DSO2820, but it's not so good. I mean, the distortion is not correct. It's quite high as compared to the QA401. You know, guys, why I keep drinking coffee? What's this out? It's already like, what's this out? Keep me alive. But I need to finish this experiment in here, so that I don't have to go back here next week and then do it again. 3, 2, 1. We got a signal on the oscilloscope sine wave, and we got the signal on the QA401. That ends the problem. I can go to bed with a big smile that I finally solved my problem. And the good stuff is that I won't be dreaming while I'm sleeping about how to solve the problem with the BTL, the bridge tie load of Class D. That's pretty awesome, guys. That's pretty awesome. Let me throw you to the PC-based equipment system so you can understand how it works. And let me start with the high power from the 220 volt AC household. We got the power meter in here. This is where I plug in the 220 volts for the SMPS power supply. SMPS power supply is a 48 volt 800 watt, and it goes down, the voltage goes down to 48 volt DC, and that is the input power to the class D power amplifier. Currently right now it's the module B TPA3255 chipset, and the speaker output, the left and the right channel, goes into the resistive load. This resistive load is 1 kilowatt, and the left and the right channel is monitored using a voltmeter to monitor the offset voltage, the left and the right channel. And then this DSO2820 is also in parallel with the voltmeter to capture the sine wave signal for the left and the right channel. And also in parallel with this oscilloscope signal is the QA401, which is used to measure the distortion, which is on my other screen on the PC. Now, this PC-based equipment, it is being hosted by a Windows PC, Windows 10, and this is the one. And I make use of external monitor to split the two signals. Normally, I can put all the signals together here in a tile, and that is pretty cool actually to have a bigger screen, which is very good for demonstration. Now, one thing that I'd like to add in here, which is necessary to capture the temperature profile, is the Unity, the UT71E, which is also a DAQ that I can connect to PC, and I can gather the data in an interval of maybe 5 seconds. That is 5 seconds and gathering all the data. That is quite good if I wanted to have the temperature profile on the heatsink. That is why I have here the UT71E. Let's see the source of audio signal, the AF generator, the audio frequency generator. I mentioned that it is traditional because it is traditional by itself, not coming from the PC base. Both of these equipment, the DSO2820E and also the QA401, they have the internal AWG, that's so-called arbitrary waveform generator, but I did not use that for a simple reason, again, on the grounding system. And this is really make it complicated. You know, the grounding system that I'm talking about right now is probably the most words that I have been uttering right now. Misuse or abuse the word grounding, the earth ground and the common ground, which is how can I explain that one really in a very simple words. There's not much about this video. Actually, it's all about the kind of experiment that I have done, the testing of experiment to solve the problem. Really, I thought that the module B is really have a problem that I even go further, keep testing other Class D power amplifier with the same chipset, the TPA3255. But really, eventually, I found it out that one of the mistake is my own mistake on the connection. I'm glad I finally found it. But I still found it out that this module B, there is something different from the other modules. Like a special one that the circuit probably is a different flavoring. So I wanted to know that. I tried to contact the seller if they can provide the circuit, and that would be awesome if I can see why it performed like this. The takeaways for this video is that probably you will have the same module as the module B, and you will know later how to deal with it in case you are also testing and making use of the PC-based oscilloscope like the multi-instrument DSO2820 or different models. Probably you will going to encounter the same problem, and then you know how to solve that. I hope my video can impart something that probably other people not yet encountered, about to encounter, and I hope this could be a good reference. Well, guys, if you have some comment, just let me know on the comment section below, and let me try to answer them as soon as I can see those comment from the YouTube channel. As you know, we're in China, and YouTube is not really welcome in here to view it without Hong Kong SIM card or outside access like Hong Kong SIM card. Well, guys, this is the end of my video. I hope you like it, and keep watching my previous videos and other videos coming in with the Class D power amplifier. TPA3255 comes with a 315 watt of power at 4 ohms speaker. You know, my way I look at it, like, is it really 315? Well, let's see about that. And to make it more interesting, I have here my Nathan baby toy, and the other one is what he called the mo. He's not here with me right now. Before we worked together as a team, working with the Class D power amplifier. That was the previous project called the DR100W concept project. We have so many good memories working together to make our performance test. Guys, really bye for now, and see you in the next video. I have to go to bed now. I have to go to bed. I still have some work tomorrow. Really, some work tomorrow.